Hopefully just be then a nice quick video, because there's only 2 examples for this unit, so modelling with vectors. So let's look at example 19. A girl walks 2 kilometres due east from a fixed point to A. So let's draw that on. So she walks to there, that's from O, that's at A, and due south to B. So we know that that's 2 kilometres, that's 3 kilometres. 2 along there, 3 down there. So she's walked that vector, but remember she's actually gone from O to A, then A to B. So the total distance travelled, all you do, as it says there, is you just add them together. So then part B then, the position vector of B relative to O. Now position vector just means you need to have it in the form of I and J. Well, we know that when we're going this way, we're moving in the positive I direction. So it's going to be plus 2I. And then when we were moving down, it becomes a negative J. So it's going to be negative 3J. So when we put those together, we get 2I minus 3J. Okay, so remember those lines mean magnitude. And when we do magnitude, what we want to do is basically, we're doing Pythagoras. You want to work out the length of that vector there. So that, again, as I just said, is Pythagoras. So it's 2 squared plus 3 squared square rooted. And if you put that into your calculator, you get that it's 3.61. Okay, so then the bearing of O from A. So what I would always do is draw out what we know. So we know that along there is 2 and down there is 3. Okay, and we want the bearing. Now remember, we always measure the bearing from north. So I'm going to actually just do that in another colour so that we can see it a bit clearer. So our north line is there, and our north line for that obviously is there. Okay, and it's asking us for the bearing of B, remember B's here, from O. So we need all of this. Well, the first thing we're going to be able to do is work out this. And the way we're going to do that is by using SOHCAHTOA, because remember this must be a right angled triangle. So then it's going to be the TOA triangle. So T equals O over A. So we're going to do tan to the minus 1 opposite, which is 3, over adjacent, which is 2. So then again, you just put that into the calculator and it comes out that that's 56.3. But remember, that is just that little bit there. We haven't yet added on this bit. Therefore, what we need to do is that 56 plus 3, 56.3, sorry, and we need to add on 90 degrees for that right angle there. So in an orienteering exercise, a cadet leaves the starting point O. So always with these, draw out what is happening. We know that that's point O. He walks 15 kilometres on a bearing of 120. So again, I'm going to add my north line in. We know that faces north. So if it's on a bearing of 120, it's going to be about there. Remember, we know that that is 120, and that's going to be 15 kilometres to reach point A. He reaches the first checkpoint. He then walks 9 kilometres on a bearing of 240. Again, we must draw that north line in, and it's 240 degrees from there. So it's going to be about around there. So then we draw that in. From there, we know that that's 9 kilometres to B. And from there, he returns directly to O. We know that this is 30 because we do 120 minus that right angle. So 120 minus 90 gives us 30. We know that that's a right angle triangle. Therefore, what we can then do to work out this length, okay, we're going to again use trigonometry. So this is our hypotenuse, this is our opposite. So our opposite, remember our triangle from trigonometry, SOH. So our opposite equals sine 30 times 15, or 15 sine 30, as they've put it there. But either way around, that's fine. Okay, and then to work out the this side up here, the adjacent, we're going to use the cos. So it's going to be, to work out the adjacent, it's, sorry, that's an H there, so it's going to be 15 cos of 30. So for this side up here. When you put that into your calculator, you'll get that. And remember, you just need to put your I and J after it because it's what you've gone along. And then that is a minus because it's what you've gone down. Okay, so then let's have a look at part B. So again, the magnitude of O to B. Okay, O to B. So what we then need to do, as it says here, is we're going to add on all of the angles we know. So we know that that is 30 degrees. We know that's 60. We know that there's a right angle. So because we want O to B, we need to do our cosine rule. Okay. Now you can get that this therefore equals 60. Then all you need to do is your cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. Sorry, that had to go underneath. Okay, so we're saying that this therefore is a because that's our unknown. So it's going to be 15 squared plus 9 squared minus 2 times 15 times 9 times cos of that 60, because remember we can work that out. And when you put that into your calculator, you get that a squared equals 171. So therefore a must equal square root of 171. So we need to work out the bearing of B from O. So basically that's asking us for this angle here. Now of course we already know that 120 because we're given it. So all we need to do is work out that theta and add them together. Now as this hint says here, we know that this is 60. But the reason we know that is because this angle here must also be 60 due to the co-interior angles found along here. Remember, co-interior angles add to 180. Now we know this length along here is 13.1 because we've just worked it out. So then it's simply the sine rule. Remember sine rule, sine A over A equals sine B over B. So then literally you just plug your numbers in. So sine 60 over 13.1 equals sine theta over 9, because remember that's their opposite. So then all you would do is sine 60 divided by 13.1 all times by 9, which gives you the sine theta. So then you just do s to the minus 1 of all of that, and it would give you that value of theta. And then remember, what you need to do is add that to 120 to give you that whole angle there. So as it says, 157, which is your answer from above, minus 90, because remember that's right angle there, gives you 67. And then you've got a right angle triangle again. So you know that that's 67. That therefore is your opposite, that's your adjacent, that's your hypotenuse. And you know your hypotenuse is 13.1. Therefore you can just use your trigonometry rules to work out your each side that you need. So I hope that's helped, and then you just put them just like that in front of the I and J, literally just like before.